Okay, so I'm gonna try to show how I'm gonna plot this real quick. So I'm gonna highlight my points, select over the points so highlighted, and then I'm gonna go to the insert and I'm gonna insert scatter plot. So hopefully this works out right. Okay, so here we have the issues, right? I'm not gonna go ahead and provide the chart title or even the labels right now because I realized that if you don't have the right design, if you go ahead and provide all this information and then you choose a new design, it resets all the titles to chart title. Okay, so I'm gonna go here and find the format I like the most before I even change anything else. Okay, so I kind of like this one here, right? This looks good, but I also like this, so it's kind of tricky. But here's the thing with this one here. I'm only showing 4 different versions. You guys have 7 versions. And if you choose to add the one with the beverage here, you will have 8 different versions. So you want to think about how cluttered this will look, right? So let me go with the first option. Let me go with that one. I'm trying to get the legend on this side. I don't know why that just came out wrong. What about this one here? I don't know. Let's try this one here. Okay, so title, let me see if I can outsource some of this. Because I actually had typed this out earlier. So I'm trying not to type all the time because, great. Okay. And then for the y-axis, let me see if I can get uh the y-axis. It's going to be what? Change in mass over change in volume. So for the y-axis, let's see if we can have mass, okay, in the unit grams. I have to add this to the title here. Mass has to be measured in grams, and then volume has to be measured in milliliters. You can say volume instead of spelling out volumes. You can just say VOL, right? Just to be consistent. Okay. So mass in grams versus volume in liters of percent sucrose solutions. They're different ones, right? And so over here, I'll write VOL in milliliters and we should be ready to go. Okay, obviously our numbers aren't looking so great, right? So let's go here. Let me click on this chart. I'm trying to make this chart represent my data set. I'm starting with the first one here. This here. So select data. We want series 1 to be 0%. So I'm gonna go here. The name has to be 0%. And then this is now just gibberish. Delete that. Delete that. We want 0%, the X data to be this. The Y data should be this, Y, and that should be okay. See, it looks so much better here, right? Okay, let me actually work on this right now because when I work on it before I bring in the others, it makes it easier. I'm gonna add the trend line, okay? Oh, I don't like this one here. Let me see if I can I switch to this? Much better, okay? Oh, it kept the names. Okay, that's a little nice treat here. It kept the names. So I'm gonna actually switch to that because I like this straight best fit line, not the dotted one. I feel like the dotted one is a little bit too busy. Set the intercept to be 0. So this is going towards 0. I'm gonna forecast it. I want to elongate this so it gets to actually 0 so we can make sure it's going 0. Backward 10. How does that look? And then we have the equation on the chart right here. I'm gonna bring this down here. Okay. Okay. That's our first one. Okay, let's work on the next one. The next one will be select data right here, series 2. We want series 2 to be 20%. So that's gonna be this one here. Okay, 20%. Okay, we're not done. Go back to the labeling, series 2, 20%. Yes, we wanna assign what the x-axis is for the y-axis. The x is still this one. This is still our x. The y is now this one, right? And look, now this looks better. So I'm gonna left click this, right click it, add trend line. Let's see, I'm gonna forecast this backward 10 periods, right? This is move this back all the way here. I want to set the intercept at 0. I want to display the equation on the line. Ooh, that looks better. This is right here. Right. It may not be the best place for this, but y'all, this is what I got for right now. Okay. Okay, let's go ahead and move to the green data. The green data here. Anyway, series 3, we want this to be 40% sucrose, right? So let me move this over. For right now, say, okay, let me move this down here. Then I'll continue with my 40% sucrose. Let's clear the X, clear this completely, clear that completely, right? Assign the X, assign the X to be this right here. Ta-da. Oh, I have to come back. I pressed enter, I wasn't ready. Assign the Y to be, this is for 40%, right? Assign the Y to be this. Okay, much better. There it is, right? 40% is a triangle one. So I'm gonna right click on that and then left click on it. So add trend line. That's our best fit line. Let's forecast back 10. It's gonna go all the way back to the origin. Let's set the origin as 0. Set the equation on the chart. Okay. Let's do the last one. Let's finish this one up here and then we'll see how we're able to. This is the best I've drawn so far. Actually, go ahead and set the data, right? This is the last series. We want this to be 60%. So we want the name of this to be 60%. Okay, great. Clear the X. Clear the X completely. Clear the Y completely. The X is now this. Oops. It should end on 10, not go to 11. So I'm going to change that to 10, right? So X should be, yes, from C6 to C10. Okay. Y should go from G6 to G10. I'm just going to highlight this to accomplish the same thing. From G6 to G10, right? Correct? Okay. So what is it? Our 60% sucrose data is highlighted. Now let me right click on that one. Add a trend line. Set intercept equals 0. Set equation on line. I'm gonna move this up here. Okay. Well, I didn't forecast this one here. Let me forecast this by 10. And then what else? I have displayed the equation of the line. I think this is it, right? Okay, so now that I have this here, and this is already set up, I can now move this here, right? So this is an order, right? 0%, 20%, 40%, 60%. So from here, I'm gonna copy the information. Y equal, I can type this a little faster. I can do better. 1.0211x. Y equal 1.1147x. So I'm just copying this from here. Excuse my horrible handwriting, but it's coming from here, right? And this is in order. So then the next one should be, I just copy this here. Make this paste. Paste. And it's going to change the slopes, right? The next one will be 1.2976, right? Let's change this last number here, the last slope here. And that will be, delete, 1.3364. Okay, we got it. So now that we have all this here, and these came from there, technically, the equation of the line is this, right? So I'm going to copy this over here, paste. And the density is just the slope. So I'm going to delete that. Okay. So let me just reset this again so that I can have. From the equation of the lines, the slope is the density. We have made sure to set each line passing through the origin, right? So I'm only working how many? I said 4 out of 7. Okay. So you go to the lab, you go through the directions, and then for this last part here, you are supposed to draw the density versus the percent sucrose. So this is a whole different graph, right? But I won't draw that first. I'm going to actually draw this one here, and I'll draw this one here last, okay? So remember, this first graph that we worked on, you will submit that. You can either draw 7 separate graphs, or you can consolidate them together like that, and you have 7 best fit lines, right, for 7 sets of data. So I'm going to make this smaller, and this will go up here. Then from here, maybe I can draw the second one. For this second one here, we're drawing percent versus. So let me go ahead, insert this best fit line. So here, this is percent sucrose solution. Okay, so we want this one to be percent sucrose solution. I don't remember if they specify this. I don't want to go ahead and look back at, let me see if I can see the directions here. If they say, I don't remember if they specify what should be the y-axis, what should be the x-axis. So determine the density of the solution. Once you figure that out, you told to plot, draw the best fit line. So we have all that part done. Will it sink or float? We're not there yet. Okay, so more the part where we're table 3, you're figuring out the densities. Table 3 is where you're figuring out the densities of the different solutions, right? 0%, 10%, 20%, 30%, 40%, 50%, 60%. I'm trying to make this video short, okay, get straight to the point. Okay, now I'm looking at where you're determining the sugar content in the beverage. The first thing they say is you're going to be graphing the data from activity 2 to create a scatter plot of sucrose percent versus density. So we want the sucrose percent to be the y-axis. The density should be the x-axis. Okay, so sucrose percent or percent sucrose. I'll put this over here. Delete. That's not what I meant to do. Okay, I just typed this in. Percent sucrose versus density of solution, right? Of solution. It's kind of implied, but I'll add it here. Okay, so I'm gonna go ahead. This is our chart. Let's label or let's insert on the chart. I'm trying to get the menus for the chart. So there it is. Let's add horizontal. Horizontal will be density and then vertical will be percent sucrose. Okay. When you go to your directions on, let's see if we have page numbers here. Activity 4, the first number, you need to draw this graph right here, okay? And you need to get the best fit line. So for this graph, let me make sure the data has been selected properly. Select data. Our title, we only have one title, which is already provided, right? That'll be percent sucrose. For this one here, the x-axis is selected as that. And then the y-axis, I think it's correct, yeah. So this is our line right here. Okay, with this one here, we don't have to force this to pass through the origin. So all we really need is a best fit line. So add a trend line here. And that's what we really need, just a best fit line, okay? So we need, you can put the equation on the chart. We don't have to actually set the intercept to 0 for this one here. So once we have that, what we're trying to figure out is we're relating the density to the percent. So once you get the density of the beverage, you can then use the density to find the percent sucrose. Okay, so let's see how this plays out. I have to draw yet another graph to figure out what the density of the beverage is. I have no idea what it is. So I'm going to highlight this again, go over here and insert scatter plot again. Okay. So even though I'm drawing 3 total with this one here really scrunched up in here, right? It's really more like how many graphs are we drawing? We're drawing 9 total graphs. Okay. This one goes with that. This one here has been scrunched up, but it's really this. This goes with that. And then the last graph goes with this. So I'm trying to just kind of put them out of the way. So you're not really hogging up all the space. But we have 7 in 1 up here, 8, and then this is our 9th one. Okay, so for this one here, we're also doing mass versus volume. So it's very similar to that one. But this is mass, also measured in grams versus volume in milliliters. So we're gonna go here, add axes, primary horizontal. This is gonna be what? Volume in what units? Milliliters. I'm almost done, y'all. I'm gonna try to make this short. It's been an effort. Horizontal, right? Oops, what did I just do? What did I just do? Add title, vertical. Okay. Just got distracted there for a moment. Okay. So this time is going to be our mass in grams. And with this here, okay, now that we have our title, we can now find our best fit line. Right click as, oh, for this one here, also we have to set the intercept equal to 0. Because remember, this is mass versus volume, like what we had up here, okay? Like the one that the many in one graph is very similar. So I didn't write the lab. I feel like they should have added the beverage. Oh, I forgot to state this here, right? We're doing this last one for the beverage. For, you can say here, Coke, also known as beverage. Okay, I didn't write the lab, but if I did, I would have actually had you guys do the beverage or the Coke as the ACE solution in the beginning. So this would have been consolidated with that, but that's not how they did it. They did it separately, okay? So it's the same thing as what we did here for these graphs, but now we're doing it not for sucrose solution, but for a solution that has sucrose in it, okay? So let's go back here and do the same thing. We already have the trend line. Let's set the equation of the line, right? We have set the intercept equal to 0. So for the beverage, this is it right here. What else do we have for the beverage? Did we forecast? We forecasted everything else. We may as well forecast this backwards. Okay. So see how the line becomes, it extends all the way down. Okay, what else do? We have the equation of the line. I think that's pretty much what we need from here. We only have one of these, right? So from here, equation of the line for this solution is y space equals space 1.2027. So I'm just copying this information here, right? Space x. Okay. From the beverage, I'm getting this information that the equation of the line is that. So from there, we can get the density of the beverage, right? I need room. Where is the density? I'll write it right here. So density of beverage based on the numbers I had and the numbers I used. Remember, a lot of things have been altered here. We have a lot of errors in our data. You can see the points are not perfect. This is what we got. okay? So knowing what our density is, oh, sorry, density of beverage, there was really no clear conclusion. Is equal to 1.2027. Is that what it is? Can I wrap text? I guess we can't really do that, can we? Okay. Yeah, so there. Density of beverage is equal to 1.2027. Okay, so we got that. Remember, we got this from here, from the slope of the line. Now that we got that, we can then take the density of the beverage and then go back here and try to figure out, wait, why is it showing percent and then percent here and here? Oh, you know what, guys? I just realized something. As I'm trying to make sense of this, I just realized these numbers are switched. Okay, the labeling here is all messed up. So this is our y-axis, right? Percent sucrose. This is our x-axis. So let me go back to this. So this is all messed up. Sorry, guys. S1212 test. Okay, so I'm gonna pick up where I left off yesterday. Yeah, I shot the last take that was actually the best take, and sadly I forgot to press record. I thought I was recording, but I hadn't recorded. So we're doing this over again. And so let's see. The last take was essentially, let me go back here, go back to home. It was essentially showing you guys how I drew the sucrose, percent sucrose versus density. Okay, so once again, going over the lab, let me go ahead and review that part. Going over the lab, the major part of the lab starts with creating the different concentrations of sucrose solutions, right? And so the lab protocol should give you directions to make the solution. You have 10%. This is before we get to this, right? We have 10%, 20%, 30%, 40%, and 50% solutions. So once you have your solutions, the next part is to draw your graph. And you can see right here, we're trying to figure out the density of the solution. So the density of the solution is obtained by drawing the mass versus volume. Mass will be in grams, volume will be milliliters, and grams should be, this should be a lowercase, but I'm not gonna mess with this right now. Mass should be in grams, lowercase, volume should be milliliters, also lowercase. And what I showed you here in this slide or in this screen is the mass versus volume graph. It's a linear graph where the slope is essentially the density. I didn't show you the graph for all the concentrations. I selected a few, 0%, 20%. Let's see, how do I get back to just, yeah, so we have 0%, 20%, 40%, 60%. Remember in your experiment, the amount of solutions that you're measuring starts with 5, goes from 5 to 10, 15. So you're adding 5 for every cycle, right? For every run. So you start off with you start off with 5 mils, you add 5 mils, and you add 5 mils until you get 25 mils. But to kind of generate different numbers and get a different graph, so people are not copying directly from here, I use these numbers right here. So that was a quick recap. Okay, let's see where we left off. So we had just left off in the last section, drawing this graph right here, showing you how you can stagger the graph and do an all-in-one graph. Instead of submitting 7 different graphs, right? You can do all in one and then pretty much plot all 7 graphs on one paper or one surface, right? After we're done with that, the next part of the experiment was to figure out the density of sucrose, right? The density, sorry, the next part of the experiment will be for us to figure out or to draw, once you figure out once you have figured out the density of the solutions. The next part of the experiment pretty much has you figure out the density of the regularly shaped objects. And the idea here is to figure out, is to compare the density of the objects and the density of the solution to figure out if the objects will float or sink in the solution. We will not cover that part here. The part I want to cover next is drawing the percent sucrose solution versus density. So the assumption here is you have the density of all 7 solutions, right? Once you have the density of all 7 solutions, which in my case, I only have 4 solutions, you will draw the density versus percent sucrose in the solution. Of course, in this case, I only have 4, so I picked 4 out of the 7 to draw. You will have 7 points to draw. When you plot the graph, just like we did before, your y-axis is going to be percent sucrose in the solution. Your x-axis is density. This right here is showing you the best fit line. So what I'm going to do, let me go ahead and start this part here from scratch. So let me stop and start this over. Okay, let's go ahead and pick up where we left off yesterday. So we're starting with taking all the densities that you have figured out of the solution and plotting that against the percent of sucrose in the solution. So this is actually part of the experiment. The directions don't really clearly point out to this part, but it's an important part of the experiment, okay? So there's a one line place in the experiment that asks you to actually draw this. So let me see if I can actually find the experiment. Give me just a moment. Let me pull this up. I probably should have pulled that out before I started this part right here, right? Okay, give me just a moment. Let me pull this up. So open. I'm trying to open the Adobe to see if I can find the experiment. Okay, so using Excel, that's not the one I'm looking for. I am looking for, okay, I'm looking for something very specific. That's not it, not conversion table. It should be here. This should be density and graphing. Let me see if I can find this. It has to do with, well, we'll do that later on. Later. It has something to do with density and graphing. So give me just a moment. Exploring density. I see it right there. Okay, cancel. Okay, let me scroll this down here and see. Oh, there it is. Explore. Okay, let's pick up where we left off. So when we left off last time, we had just drawn the mass versus volume graph for our 4 solutions. Remember, I just selected a few of the solutions. Now I want to show you where I am in the lab, okay? So I have managed to pull in, let me minimize the screen so that you guys can see what I'm showing you here. This is a lab procedure. So as far as the process is concerned, we have just gone through the first part here. I'm trying to tie this into the directions, right? We have gone through the first part. We have made our first solutions right here. I'm not actually going through and talking about the solution, right? Making the solution. I'm trying to focus on the graphing part. So the next part is, I'm not going to go over this part here because it has nothing to do with solutions. Sorry, I'm not going to go over this part. It has nothing to do with graphing. Let's go ahead and start where we left off yesterday. Where we left off yesterday, we're talking about let us go ahead and pick up where we left off. Okay, we're picking up where we left off. So we just drew the mass versus volume graph. And from here, we're able to figure out the equation of the lines. And I pull those out and place them right here so that we can see that the slope of each line, since the line was actually directed towards the origin, so it was adjusted to make sure it went through the origin, we're able to determine that the slope of each line is essentially the density of the respective solution. Once we have that, our next charge, let me go ahead and pull in the directions, is to draw. I'm going to skip over the part that is not graph related. The next part right here, we just figured out the densities of the solution using the graph. We drew mass versus volume using our data right here. So I won't go over that again. As you can see right here, the mass that we're measuring was for 5, 10, 15, 20, 25. I am done with that part, right? And then of course we got the equation of the best fit line where the y-intercept was equal to 0. We got that. And then from there we figured out the slope of each line was the density, right? So we're done with this part. Okay. Now the next part of the activity is, once you have the density of the regularly shaped objects, that's the cylinders, you will compare the cylinders to solution to predict whether the cylinder will float or sink in the solution by comparing the densities. I'm not going to go over that, but you write your predictions and do the actual experiment to see if it plays out. If you say right here, aluminum will sink in the 0% sucrose solution, but then you try it out and it says it actually floats, you want to write here, you predict it will sink, and then you write what you actually experience in the experiment, right? I'm not going to go over that part. This is what I want to go over. Here we're told in number 1, use the graphing program and the data from activity 2 to create a scatter plot of sucrose percent versus density. This next part is for this, okay? So we're going to do sucrose percent right here versus density, okay? So let me go ahead and make this part here bigger. This is what we're working on right here, sucrose percent versus density. So for this part here, like I did before, let me go to home. I'm going to highlight this data and I'm going to insert, and my goal is to plot a graph right here. Okay. We want the percent to be the y-axis. We want the density to be the x-axis. Okay. So a chart title can be percent sucrose versus density of solution. Okay. I was about to say sugar solution, but solution is fine. I don't want to write too much. I want to keep this short and sweet. Okay. Just like what we did before, let's go ahead and label this graph, and then we'll do the best fit line. We'll do everything that we did for the other graph. Primary horizontal. Our horizontal axis is density, correct? So we have our density here. Density. Our vertical axis is, where is that? Percent sucrose. What does it say so? Okay. What happened to the label? I'm trying to label this, but I'm not seeing it. Hold on just a second. Let me try this again. Oh, there it is. Okay. The title of the axis here is percent sucrose. Let me see. Did I get it? Oops. Okay, so we got it, right? So from here, let me go ahead and enlarge this so I can zoom this closer, right? So we can see. I'm going to right click and then add trend line. We want a best fit line. This one here does not have to have, it does not have to actually go through zero. We don't have to set the intercept to be zero, but I do want to have the equation of the line. So I need that part. What else do I need? So what this equation gives us is a relationship between percent sucrose or percent sugar in the solution and the density. Why is this important, you ask? I'll tell you why. It's important because we can use this equation to find the percent of sucrose in our beverage. Exactly. So once we have this here, I can then go ahead and close this. I'm done. I have my graph. I'll come back to this graph later on. Okay. Right, I'll come back to this later on. So we already went ahead and drew this part right here. I think we did this part here, right? We already drew the mass. Just in case, let me go ahead and work on this part again. Okay. Okay, so we just drew our graph of percent sucrose versus density of solution, and we're gonna come back to it. So let's go back to the directions of the lab. Going back to the lab directions, where are we at? We're right here. Okay. So I'm going to bring in the lab direction so we can see where we are. We just finished with that graph. We just finished this part here. And then we're told our goal is now to figure out the percent sugar or the sugar content in the beverage being the flattened Coke, right? For us to do that, you repeat the experiment, what you did to measure the mass of the different volumes of the sucrose solutions. You will do the same thing. What you did in activity 2, same thing. You measure out 5 mils of the sugar, add 5 mils to that to get 10 mils, and you measure the mass each time. So the mass of 5 mils of the beverage, then add 5 more to get 10. What's the total mass? Add 5 more to get 15. What's the total mass? After each additional 5 milliliters, you're figuring out the mass, right? Once you have all that, you will put it right here, get the mass of the beverage versus the volume of the beverage. And so essentially, this is what we have right here. Did I keep this consistent? Yes. Just like I did earlier, I'm not doing 5, 10, 15, 20, 25. I'm actually going in tens, what, right? Once again, the purpose of this is to make sure that you're not just, getting it from here. You're actually doing the experiment. Well, I can actually talk about this too. Okay, let's go ahead and work on this part here. So I'm trying to figure out the mass versus volume like we did earlier. Mass has to be in grams. So let me put grams here. Volume has to be milliliters, right? And we're trying to figure out the density of our flat beverage, which is Coke. Okay, let me highlight once again my data set. I'm going to insert, I'm going to select a scatter plot. Let's click on that. This is my, let me see. I want my x-axis to be volume and my y-axis to be mass. Is that what we have here? I want to say it's what we have, but just to make sure, let me go back to select data. Is that what we have here? It looks like it's what we have, right? And the chart title, we can title the chart. Can I get a title from here? I'm trying to see if I can get the title from there. Okay. What's the thing that gave me the title here? Okay. Anyway, somehow it's not working out, is it? No, it's not working out. Let me go ahead and type it. I was trying to do what worked before, but it's not working. Okay. We're gonna be doing mass in grams versus volume in milliliters. Okay, we got that. Okay, let me go ahead and label. Oh no, something changed here. What changed? Okay. Let me delete this part here. And then go ahead and select X values. My X values are going to be volume, right? Then my Y values for this graph. Okay. It looks like it's working again. Okay, so I got my X value, I got my Y values. Okay, now I have to insert my labels. So here, let's go ahead and set this up. Primary horizontal, that's going to be volume in milliliters, right? Delete that part. And then click on this again, and then primary vertical. That's going to be what? Your mass in grams. Mass in grams. Okay. Okay. So we have our title, we have our labels. Let's go ahead and right click one of the points and then add a trend line. We want a best fit line. We don't necessarily want this. Oh, sorry. No, we do need to have this. Let me forecast 10 down this way. On display equation on chart. What else did we do? We want to make sure that the intercept is set to 0. Is that what we have here? It looks like it. Yep, this is it. So by having this here, we can then say the density. Okay, we got exactly that. Yeah, this is our equation. Because of that, the density of Coke or a beverage is 1.2027. There. Okay. So summary. For this graph, these are all, for this experiment, which is kind of about graphing, but also about exploring density, we are drawing a total of, well, up here for this first graph, there should be 7 of these best fit lines, right? For 7 different solutions. Our second graph is right here, and there should be one of this that relates percent sucrose to density. Our last graph should be this one right here. You want to include the graphs in your submission, right? Mass versus volume. I haven't set it here for beverage. And our beverage is what? Coke. So I can put here, this is Coke. Okay, this lesson for the beverage. But now that we have the density of the beverage, we selected right here, density of Coke, we can then use the known density to figure out the concentration. Now we can do some math here to solve for it. Okay, or you can use the graph. I believe the intention was really for us to use the graph. So I am going to use the graph, but you can always use math, right? So for the graph, we'll estimate where the 1.2027 is. It's close to this number right here, slightly above it. So imagine this was straight, right? You go all the way here, oops, there, and then go to your, you want to use a ruler for this part. I don't have a ruler, sorry guys, but there. So we're saying at about 1.2027, the sucrose percent is around what, 31%? So that means that for the beverage, percent sucrose from the graph that relates density in sucrose is about 31%. Am I estimating this amount? Yes, I am, because it's based on the graph. But let's see if we actually do math to solve for this, what it works out to. Okay, but technically the purpose of this here is for you to be able to see the relationship. So let's see how this plays out when we actually do math. So our equation shows over here, up here, our equation shows the relationship between, let me click on that. The relationship between, okay, I think I moved this over, right? Let me delete this part right here. Okay. So let's go back to clicking that. Okay. I have y equal 1.6802x minus 1.7035. Okay. Okay. So y is what? Y is percent sucrose, right? That's the y-axis. And then X is density. So let's go ahead and do this. 1.6802 times density. Oh, sorry, I'm writing here, you can't see. Minus 1.7035. Okay, so we already have the density of the solution, right? We said for our soda, for our beverage, which is Coke, the density is equal to, we said it was 1.2027, right? Grams per milliliter. So we'll say percent sucrose. Let me write it abbreviated. It will be 1.6802 times 1.2027 minus 1.7035. So let me go ahead and work this out and see what we get. So 1.6802 times 1.2027, let me press equal, minus 1.7035. Did I set this up correctly? So we got okay. So what I have here for percent sucrose is 31.7%. Actually, I get 0.317%, which works out to 31.7%. But let me see what is we're looking at here. Yeah, so we have this number. Okay. So when you plug this number in there, this is what it should work out to. Once again, you multiply the numbers on top. Let me see how this works out again. 1.6082 times 1.2027. Oh, I messed this up. Okay, so we're trying to do the math here, the math to verify our answer. You can see how I did it with the graph, right? Where the graph just line this up over here, and then this should give you this, okay? Now, what we have here, since we have a percent sucrose, I'm trying to see when they got the best fit line, if they did something to this. Anyway, let's go ahead and do the math and wrap this up. So our math shows that we have the equation right here. We have y equal mx plus b, right? So I put the slope of the equation here, the value of density of the beverage here. I'm trying to solve for percent sucrose. So 1.6802 times 1.2027 equal minus 1.7035. And we get 0.31, right? So this is going to be the same thing as 31.7%. Okay. So our percent is very close to 30%, right? But you see that verifies it. Any questions about this process? Okay. So Okay, I'm trying to get this best fit line equation to make sure I got this right. Okay, let us see. Okay, so I'm having to record this second part over again because the equation was kind of messing up later on. So I'm going to focus on redrawing this part here. Let me go ahead and erase this. So we're starting where we left off. I've been having a lot of issues with this graph because things are not working on exactly how I thought it would play out. That's okay. That's the reason why I'm working on this, to make things easier for you. Okay, let's go ahead. So when we're drawing when we're done with the first graph, which it shows right here, right? That we just drew the mass in grams versus volume in milliliters graph where the y-axis was mass in grams, x-axis was volume in milliliters of the percent sucrose solution. Remember, you have 7 solutions. I'm only drawing 4 out of the 7. In your experiment, you were measuring 5, then 10, then 15, then 20, then 25. I am measuring 10, 20, 30, 40, 50. I'm trying to make it different enough so that your answers will not be the same as mine, okay? So once we've drawn the first graph that has, in this case, 7 and 1, because I kind of laid them, I stacked them over each other, so I wasn't submitting so many graphs or creating so many graphs, generating so many graphs. Our next graph, according to the directions, is, let me see if I can find the directions somewhere here. They should be somewhere here. But anyway, our next graph is going to be percent sucrose in solution versus density. And so our x-axis will be density, our y-axis will be percent solution. I already drew this, but I noticed I'm having issues with the equation of the line. So I'm going to try to draw it again to see if it works out better. Okay. Remember the y-axis is percent. So let me go ahead and title this. So we have percent sucrose versus density. Okay, let's go ahead and add chart elements. I'm going to label the horizontal axes, and this should be what? Density. And density is measured in what? Gram per milliliter. So let me make sure density, this is measured in gram per milliliters. Okay. Next part is the y-axis, which we have what? The y-axis is going to be the vertical axis, and that one is the percent sucrose in the solution. So percent sucrose solution. So it's percent sucrose solution or percent sucrose in solution. Either one works because it's pretty much the same thing, right? And this is what we're plotting. So we already have our data plotted here. Let me try to zoom this in so we can focus on just this part here. This is what we're working on. I don't want to confuse this with the first graph. So let me zoom in and then go lower so that we're highlighting just this part here, right? Ignore everything else. I'm going to right click on the data, add trend line, okay? And then let me forecast backward just 1. Let me see how that plays out. 2. Oh, that's going down. My bad. This is okay. So I don't want to do that. I want to change that. So delete that. Make this 0. What if I go forward? 1. Period. Okay. Let's see what that looks like. Okay. Let's try 2 periods. Oh, wow. Okay. So let's go back to 0. Okay. I think I'm kind of complicating this. Anyway, so we have our best fit line drawn, right? Get the equation of the line. So we're back to this again, equation of the line, right? And then we don't really need this intercept to be at 0. We need the equation of the line though. Okay, now the numbers look more like what I was looking for. This is what we have for equation of the line. I'm going to go ahead and use this equation. I'm going to copy on my iPad and then use this equation to solve for the value, okay, the value of the percent sucrose in our beverage. So from the best fit line, we get y equal 168.02 x minus 170.35. Okay, remember y is percent sucrose in solution, and then we have 168.02, and then x is going to be the density of the solution. So we're seeing that the density of the solution can be used to calculate percent of sucrose. Okay, once we've had the sucrose versus density relationship, remember sucrose is in percent, density is in grams per milliliter. Let me close this out. Okay, so I'm going to set this aside for right now. Okay, so we already have the density of Coke, and now we can use the density of Coke to determine percent sugar. So I have this already. Density of Coke is density. Oops, you cannot see what I'm writing, can you? Okay, let me scoot this to the side. You all see all this paper I have, right? Density of Coke is equal to, is it 1.2027 gram per milliliter? Let me verify I copied the right answer. Okay. So percent sucrose then is equal to 168.02 times 1.2027 minus 170.3. Is this 3.5? Let me make sure I'm copying the right numbers, right? We don't want to do all this work just to realize we didn't copy this accurately. Yes, 3.5. Okay, let's work this out and see how it plays out. Okay, so I'm gonna plug in my numbers. I have 168.02 times 1.2027, right? Press equal, minus 170.35. Let's delete that. Oh, I got some things here I shouldn't have. Some numbers. Okay, I end up with 31.7% sucrose. So from the little experiment that we did, we can say Coke has 31.7% sucrose. Okay. Yeah, and this is the gist of it, okay? Now this is based on what I did, which is not necessarily accurate. I generated data that has a lot of errors in it, okay? So just FYI. Okay, so with that, we are done with the major part of this experiment. The goal was for me to explain the graphs. Hopefully that is clear enough. And I want to end this. So if you have any questions, go ahead and contact me. Send me an email or contact me on Teams. Okay.